Hi, I'm Ron Duncan, Director of Research for Saddle Rock Technologies. Saddle Rock Technologies has developed an engine called the Total Expansion Engine. And today we're here to give you a little discussion on why it's different and to show you a live demonstration of one running. This is the lab model that we will be running later in the documentary. Basically, we have a combustion chamber here, an injection system for fuel and air here. In this portion of the engine, there is an expansion ring, and this is the exhaust pipe. This is the engine block. We use this as a starter, and all our timing and fuel delivery are electronically controlled. Now, first, a little discussion on why a total expansion engine. Basically, piston engines, as are currently used today, the Otto cycle and the diesel cycle engine. By the way, the Otto cycle, William Otto invented it, and that's why they call it an automobile, but they misspelled the poor guy's name. He's William Otto, O-T-T-O, for those of you that want to look up history on the internet. And Rudolf Diesel did the diesel engine. So both of those engines share some common characteristics that lose a lot of efficiency out the tailpipe, and we're going to talk about one now. We're going to have to pretend that the top of my fist is the piston and that my elbow is the crankshaft. So we're going to start at top dead center like all of these cycles do, and we're going to suck in a charge. Now we've got a charge in the engine that was pushed in by the atmosphere, and we call that a unit volume. Okay, that unit volume does not change, and if you were to stop right there and blow it up, it gets 7.5 times bigger. So you could imagine that's quite an increase. Now, in the normal Otto and diesel cycle, that's followed by a compression portion, which is a half a revolution. Then we explode that mixture, and if you notice my elbow, I'm directly over my rotating moment, so I have no leverage at all. I have high pressure here. The pressure decreases as we finally get some leverage over here, and then decreases again to bottom dead center. Now we still have the other 6.5 volumes, and now we're ready to exhaust, and we push those right out the tailpipe, having never done any work at all. The difference with the total expansion engine that you see here is that the stroke from top dead center here to fully expanded here allows us to take the gases completely back to atmospheric pressure, taking thus all of the power in the fuel out before the exhaust cycle. Now, the exhaust cycle in the case of this engine, you'll see when we run it later that you'll get a fine mist, sort of a cloudy looking hydrogen, which is really water vapor. So you're seeing a true zero emissions engine here today. We're now going to run a live demonstration for you. I'd like to introduce Jim Allen. He's the fellow who built all the electronics that control various devices. Today we'll be firing on hydrogen fuel, the fuel of the future. So Jim, you can start when you like. Water is the only byproduct, therefore you have just seen no pollution engine.
What fuels will the total expansion engine run on?
The engine, as it exists today, will run on a family of gaseous and liquid fuels, those being some that we've run in the lab are hydrogen, methane, propane, acetylene, MAP gas, and in the liquid group we've run gasoline. We believe we can run ethanol and diesel mixed with other igniters. So probably a family of possibly 10 fuels.
What kind of fuel economy can we expect from the total expansion engine?
At any given horsepower level, the engine will require 30% at least less fuel, possibly more. Professor Sarignano at the University of California, Irvine, did a computer simulation of the engine, and he predicts at least 30% less fuel use.
Does the total expansion engine produce much pollution?
The engine, because it produces the same amount of horsepower using less fuel, automatically has a lower pollution level. As you saw earlier in the film, in the case of hydrogen, the only combustion product is water, therefore the pollution level is zero.
How does the total expansion engine differ from the Wankel rotary engine?
First, the Wankel is not a true rotary engine. The total expansion is a true rotary engine. The common problems associated with the Wankel engine have been solved in the total expansion design.
Is the total expansion engine complicated, and will it be costly to build?
The engine has only 2 moving parts. They're readily adaptable to all high production methods used today. I'm going to take off the combustion chamber first. You can see that it's held on with only 4 bolts. So we'll pop these right out of here. Okay, this is the complete combustion chamber that I'm setting aside now. I'm going to hang it here on the wires, we hope. Now we'll proceed to taking off the cylinder head. Okay, we've gotten out all the bolts. Now we'll simply slide the cylinder head forward. And thus, you now can see the inside pieces of the engine. This is the external expansion ring, and this is the sealing rotor. Now I'm going to turn those for you so that you can see how they function. You'll note that this is passing through the rotor, and this is a piston, and this is a piston, so we fire at each piston each revolution, making this the equal of a 4-cylinder car engine that would have 60 plus internal parts. We have 2.
What applications do you see for the total expansion engine in the future?
The engine is useful for automobiles, trucks, stationary generators, or any other place an internal combustion engine is used. We are currently testing an advanced concept model that will evaluate all the parameters such as fuel use, emissions, horsepower, longevity, and a list much longer.